Hey guys, welcome back. So today we will discuss about solving trigonometric inequalities. Trigonometric inequality is nothing but an inequality of form given below, which involves at least one or more trigonometric functions. So here we compare two or more trigonometric functions. So let us find the solution set of inequality sin x greater than 1 by 2. That is, we want to find the values of x for which the function sin x is greater than 1 by 2. So let us see how to solve this. So sin x should be greater than 1 by 2. So first let me plot the sin x graph. So here you can see this is the sin x graph. Now this is the one function which you know, and I'll plot the other function which is 1 by 2. So y equal to 1 by 2 is this line. So now I want to find the values of x for which sin x is greater than 1 by 2. So to solve this kind of inequalities, first what I'll do is I'll find the values of x which sin x is equal to 1 by 2. So this is nothing but the intersection point of sin x equal to 1 by 2, which is x equal to pi by 6 and x equal to this point. So this point will be x equal to pi by 6 and this will be pi minus pi by 6, that is 5 pi by 6. So of the values of x between x equal to pi by 6 and x equal to 5 pi by 6, the curve sin x is always greater than y equal to 1 by 2. So these are the points which satisfy the inequality. So the points between x equal to 5 by 6 and x equal to 5 pi by 6 solve this inequality. So this would be the obvious answer. But we know that sin x is a periodic function with a period 2 pi. So sin x repeats always after a period 2 pi. So we have to add, to make this a general solution, we have to add 2 pi radians to both the sides. So this would give us the answer 2n pi plus pi by 6 less than x less than 2n pi plus 5 pi by 6. I hope this is clear. Now let us solve one more example. Cos x greater than or equal to minus 1 by 2. Again, first we'll find the values of x for which cos x is equal to minus 1 by 2. First let us plot cos x function. So this is the cos x graph, and I'm plotting y equal to minus 1 by 2, which is this line. Now I'll find the points of x for which cos x is equal to minus 1 by 2. That is these points and this point. These are the 2 points at which cos x is equal to minus 1 by 2, and these points can be obtained as x equal to minus 2 pi by 3 and x equal to 2 pi by 3. So at this values of x, cos x is equal to minus 1 by 2. But what I want is cos x should be greater than minus 1 by 2. That is, I want this part of the cos x. Okay. So these are the values of x between minus 2 pi by 3 and 2 pi by 3. The answer would be x equal to, let me erase this. So the answer would be x x lies between x equal to minus 2 pi by 3 and x equal to 2 pi by 3. So between these values of x, the cos x is greater than minus 1 by 2. Again, cos x is a periodic function, so with a period 2 pi. So to make it a general solution, I would add 2n pi on both sides. So this is how we solve trigonometric inequalities. Thanks for watching.